In this video series, I work through a math problem or problems each video. When factoring the generic expression ax squared plus bx plus c into two factors, px plus m and qx plus n, the following conditions must be met. pq must equal a, pn plus qm must equal b, and mn must equal c. Let's take a look at the examples. We need to factor the following expressions. Let me once again write the formula that we're going to use to the right here. So that we can match up the letters here to the letters here, let me go ahead and expand the expression here. Now that we expanded this expression, we can match the coefficients. The coefficients of x squared are a for the original expression and pq for the expression that we multiplied out. So a must equal pq, and similarly b, the coefficient of x, must be equal to pn plus qm, and finally the constant term c must be equal to mn. So whatever numbers we choose for p, m, q, and n, they have to satisfy these three conditions. The first term, or the first expression we need to factor, is 10x squared minus 29x minus 21. Let's go ahead and write the factors of 10 and 21 first, since when we factor ax squared plus bx plus c, we're going to be factoring a and c, because the pq here are going to get factored into the p and q here, and c, which is equivalent to the mn here, will get factored into m and n here. So the factors of 10 written in pairs are 1, 10, and 2, 5. The factors of 21 are 1, 21, and 3, 7. Let me start writing the expression we get when we factor this original expression. So we know that we get two sets of parentheses, and we get x and x here. Next, when we choose which pair of numbers we're going to use, what we need to keep in mind is that we usually don't use one and the other number as the factors here, because if we look at the factors, if we have 1 as one of the factors, because 1 is a small number, it's going to make the other number really big. And usually, if we end up choosing a really big number for one of the numbers here, that's going to make the middle term really big or really small. So if we look at the terms and they're about the same size, or the middle term isn't unusually large or small, that's a good indicator that the factors that we're going to be using for P, M, Q, and N aren't going to be too large. So Of course, there are times when you might see 110 or 121, for example. It's probably a good idea to go ahead and use the other factors and check them out first before trying to use the other factors. So with that in mind, let's go ahead and try 2, 5, 3, and 7 first. And since 10 is a positive number, we're going to use positive 2 or plus 2 and plus 5. And we're going to see which order of 3 and 7 will fit here. Let's see. Since the number 21 is minus, we have minus 21 here. That means that the factors that we're going to choose will be one positive number and one negative number. So that means the factors we're going to be using are plus, 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 and minus. So we have just 1 minus and 3 plus. So if we look at the middle term, since 3 out of the 4 numbers we choose are positive, the two middle terms that we end up with will be one positive and one negative number. So that means that if we add them together, they're going to be the opposite signs. So they'll essentially travel on the opposite directions in the number line. So we just need to subtract to see if we can somehow get 29. If we choose 3 and 7 and see what happens, we get 15 and 14. Now, if we can add these numbers together, we're going to get 29. But we just said that we're going to be make one of the numbers 15 or 14 positive and the other one's going to be negative. So if we choose 3 and 7 in this case, we'll end up with plus 1 or minus 1, since the difference between these two numbers is 1. So we can't use 3 and 7, at least not in this order. So instead, let's go ahead and switch the order of these two numbers. So we'll write 7 first and 3. Now, if we calculate the two middle terms we're going to get, we get 35 and 9. If we subtract 9 from 35, we get this is supposed to be 6. So if we subtract 6 from 35, we get 29. And in this case, it matches. We just need to make sure that the 35 is going to be the negative number, since we have a minus 29. So if we make this minus, then we need to make this plus, and we end up with minus 35 plus 6 is minus 29 as the middle term. So if we factor 10x squared minus 29x minus 21, we end up with 2x minus 7 multiplied by 5x plus 3. Next, we need to factor 2x squared plus 13x plus 15. Once again, we write the factors in pairs. So 2 will factor into 1 and 2, and 15 will factor into 115, and 3, 5. We only get one choice here, so we are going to have to end up using 1, even though I mentioned earlier that it's unusual to use a 1. But in this case, if we don't have a choice, we're going to have to use it. So we'll get x and 2x. And once again, but in this case, since we do have an alternative 3 and 5, let's go ahead and use that. We'll try 3 and 5 first and see if it works. Since both 13 and 15 are positive, we know that the numbers we're going to be choosing will be positive. So we have 4 positive numbers, plus 1, plus 2, and in this case we're going to be checking 3 and 5. So plus 3 and plus 5, or the other order, plus 5 and plus 3. So that means that the two middle terms we're going to be adding are both going to be positive. So they're going to end up working together and increasing the magnitude. So with that in mind, let's see, 3 times 2 is equal to 6, and 1 times 5 is 5, and 6 plus 5 is 11, and that doesn't match the 13 here. But let's go ahead and try 3 and 5 in the other order, 5 first and 3. Then we get 1 times 3 is 3, and 5 times 2 is 10, and 3 plus 10 is equal to 13. So now the middle terms match up as well. So if we factor 2x squared plus 13x plus 15, we end up with x plus 5 multiplied by 2x plus 3.